So I want to look at another question from your homework from 4.2, binomial distribution. So again, by definition, what a binomial experiment is, it's a binomial experiment is a probability experiment that satisfies these conditions. So things that we have to pay attention to in our problems is the experiment has a fixed number of trials where each trial is independent of other trials. So this independent part means that the probability is the same for each event. So remember, like one of the things we can't do is not replace a card in a deck, because if you don't replace a card in a deck, that without replacement can cause an effect on the probabilities. So there's got to be a replacement for the probabilities to be independent. The other part of a binomial experiment is there's only going to be two outcomes, a success or a failure. Then the other thing, like I said, the probability of success is the same for each trial, as we were mentioning. That's where that independent stuff comes in. And the random variable X counts the number of successful trials. So X represents the successful trials. A lot of times we'll be using P to represent success, and Q would represent failure. So notice how, again, we have this N is the number of trials, P is the number of probability of success in a single trial, and Q is the probability of a failure. In other words, 1 minus the success probability. And then X represents the random variable of the successes. So if there's whatever the N trials are, is the successes can go all the way up to what N is. So since we got this down, let's try to unpack this now and look at an example. So this example involves a histograms. So the following histograms each represents a binomial distribution. Each distribution has the same number of trials in, but they have different probabilities of success. So what we want to do is we want to try to figure out what the probability distribution is that goes with each one of these histograms. So remember, a binomial distribution. So remember, a binomial distribution, what we're going to have then is a table. So it's going to mirror like the probability distribution table as well. So in this problem, let's look, for instance, at A here. Let's look at this histogram. Notice that we have 4 bars in a histogram. So notice that this basically means 0, 1, 2, 3, 4. Notice how our number of trials would be 4. What we don't know necessarily is the probabilities. So this is what we're trying to figure out, is these probabilities here. We're trying to figure out which one of these probabilities goes with each one of these. So this is the stuff we don't know at this point. But the number of successes can vary. You could have 0 successes, 1 success, 2 success, 3 success, or you can always have up to 4 successes. So when we make our binomial distribution table, basically what we do is we have our 0 here. And what we want to do is find what the probability is of 0 successes. So for this table here, let's use 0.4 as our probability. So using our little binom formula, so I think it was binom probability distribution function, that was our formula. So the number of trials was 4. Right now, we're going to be doing a probability of 0.4. And then the successes, we're going to start with this 0. So that's kind of going to be what's going in our formula. So using our calculator, it's kind of a little blurry, but above vars is this distribution. So hit the second button and hit vars. It'll take me to my distribution formulas. So A is what we're looking for. A is the one that we have there. So notice that binom PDF is the one we want to do, and it'll determine our probability for us. So we have 4 trials, our probability of success is a 0.4, so 40% chance of success. And we're saying, suppose we don't have any successes at all. What's that going to look like as a probability? So if we put that in, we're going to get this 0.1296, or we would say about 0.130. Suppose I want to determine the probability of one success. So if we do that, same thing, second vars, go back to the binomial formula. But now we're going to change our x to one success. So we're saying there's a 40% chance of successes. And what's the chance of getting just one success? So that says 0.345. So that'd be like 0.346. So if we keep doing this, we got to go up to 4 successes. So we have a little bit to do in our table. So if we hit the second vars, get to our formula again. And again, this time we're going to go for 2 successes. And then we get 0.346 again. And then if we go to 3 successes, change it to 3. It's going to give us now 0.154. And then 4 successes. We do that one. Move it to 4. Get 0.026. So what we're trying to do now is see if we can match the histogram. So look like it's really low at the beginning, but it's also really low at the end. So to me, it looks like low at the beginning is this here. Notice how that's not looking right either. That looks like 0. We got 0.13. Do we get 0.13? So it looks like 0.13 would be like A. 0.346, 0.346 looks good. 0.154 for that looks good. And then 0.026. So that looks like that's actually A. I thought it was going to be the other one. So A is actually where the probability was this 0.4. So if I want to do the probability of this 0.5, I basically kind of do the same thing. And we're going to try to figure out how that's going to actually affect our problem. So let's see if we get this thing to see here. Get my eraser going here. So now we're doing like the 0.5 probability. So again, we're doing the binomial distribution formula because again, we have 4 trials, but now our probability is 0.5. And what our question is what's the probability if I do this 4 times, what's the probability that I don't get successes at all? So to me, let's see where this takes us. If I do that binomial formula again, but notice how this time we're changing our formula to a probability of 0.5. We're trying to figure out how that affects our problem. So this should now be 0 again. And notice how now we get this 0.0265, 0.0625. So 0.063. So if I do the probability of one success, lost myself here. Let's clear this all out. Try it again. You can also hit like alpha A if I could find A. Looks like right there. That'll take us straight to it. So 4.50, I guess that 0.063. So again, if I go back to that again, now if I want to go straight to A, I can just hit alpha A, and then I could go down there and just change that to 1. That gives me 0.25. And if we go do that again, and now change it to 2. That gives us 0.375. So 2 would be 0.375. Notice that since our probability is a little bit higher successes, notice that these numbers are moving where I get a little bit better chance for successes. So I have a lower chance for 0 successes. I have a lower chance for 1 success, but notice how since my probability is higher, I should have a better chance of getting more successes. So as I move forward, I should be getting higher numbers. That's starting to make a little bit of sense there. So again, if I do alpha A again, if I can see that, and that's going to be now a 3, and we get 0.25. So 3 would be 0.25. And then the 4, we do that one. Change that to 4. This is 0.0625. So 0.063 again. So that kind of makes sense as well that there's a bell-shaped curve to this because we're talking about 50%. So that one should sound more bell-shaped curved as well, 0.063. So now see how this one here looks very symmetric. That makes sense for 50%, that things are kind of balanced out there. So it looks like the 0.5 goes with B. So that means that C must be going with the 0.7. Notice that since there's a 70% chance of being successful, notice how it kind of skews where it's heavier on the right side. So this is kind of skewed left a little bit. But that would make sense that since we have a higher probability of successes, that the graph should be a higher rate of success to the right. Especially notice how that 3 really jumped up there to more like 40, over 40% chance of being successful because of that. So that's got to be C because of that. That starts to make a little sense there. So now you kind of look at it, it's like, the 50%, a histogram should kind of look balanced. The 70%, it should be kind of skewed more heavily where we'd call this skewed left, but notice how the least successes is to the left and the better successes is to the right. And that makes sense because the 70% should give us a heavier amount of successes to the right there. So you can kind of start to see some patterns there where you actually don't even have to do the table. So that's kind of how we would do question 2. See if that helps you out.